help companies in their journey to AI, right from building MVP products to platform engineering to data engineering. Uh, and also, and after companies have a lot of data, they can leverage that data for any AI enabled uh, products or features. Uh, so yeah, and we have offices, in a few places in India, Chennai, Bangalore, Pune, and also we have offices in London, the US, Australia. So yeah, I think so. We'll get started. So my colleague Prabhakaran is going to be speaking today. He is a full stack developer and he has a keen interest in AI and machine learning. He's always exploring new things. And whenever we have any internal discussions around AI, that you will definitely see a strong. So I'll leave it to Prabhakaran. But before that, just wanted to share the restrooms are over here. You can get water and snacks inside. Yeah. Over to Prabhakaran.
Cool, yeah. Thanks a lot, Alex. Yeah. So hi everyone. So I'm Prabhakaran. Cool. Is it audible now? Thank you. So hi, I'm Prabhakaran. So I've been building software for a decade now. So today we're going to talk about something that when I solved it last time, I really was like, it was a happenstance. I got a chance to solve this problem quite some time ago, but I learned a lot during that period. I struggled a lot to be, frank, because then there are some of the tools that is available today that is not available then, like 4 or 5 years ago. So there were a lot of manual step and so many things involved. Now that I see a new, stuff emerging, when I see it with this new pair of eyes, I can see a lot of things could be done better. So this is what it's all about. So today we're going to discuss about recommendation engine. So they call Rexes. Anyone have heard of recommendation engines? Have interacted? Prior experience? Yes, no? Show of hands. Cool. So what was interesting about recommendation engine is like they are like, I mean, at the face of it, they seem like they're just a regular, one of the data products. But underneath, if you look deep into it, there are a lot of things that comes together to get a recommendation engine with. Right? So to begin with, right, like I wanted to set a motivation, right? Why do we even need a recommendation engine? Some of you might know why, but we want to take it from a fresh view so that like we all of us are in the same understanding, right? Uh, so anyone can guess what is this? Cell phone? Yes, correct. Any particular anything that comes to your mind other than cell phone? Any guess? You can make a wild guess and it will be phone. Give me a second. I think I get the screen share. Cool. Thanks. So any guess? What is this? Yep. So this is Motorola Dynatac 8000. So this is the first cell phone that that was invented. Somewhere around 1973 it was first invented, and then 1983 it was released to public. And this is the only phone in 1983. This is the only cell phone you can have. No. So what do we have today? Any guess? today we have paradox of choice, right? Because back then we had just one choice to choose from. It was no brainer. Like you want a cell phone, that's all you have. But today we have paradox choice because why? We had a lot of options today. And when we think, wow, we have a lot of options, that's when you get to this analysis paralysis, right? And basically what it means, like you want to choose something, but there are so many n number of options. Which one would you choose? And for us, right, solving a problem is something that keeps us engaging, right? If something keeps us engaging, we will just do it for the heck of it, right? So and I don't know how many of you face this buyer's remorse is like when you buy something on a and then you regret that, oh my god, there is a new version of it or there is a better offer. So that's buyer's remorse. And together they all get us to this decision fatigue, right? So many decision fatigue. So basically to get a motivation is like today we have a lot of options to choose from regardless of that what we are trying to do, right? This options also give us this sort of new problem. I think we created a problem which we are trying to solve with recommendations. So that's pretty much the motivation for that. So welcome to the talk, thinking fast with LLM, enabling personal product discovery and recommendation. So when you, I mean, like you would have seen this title at least, right? When you signed up. So anything that comes to your mind, this title rings any bell. Okay, what is that? Yes. So there is a book called Thinking Fast and Slow by Daniel Kahneman. He is one of the, what is it? He's called father of behavioral economics. I didn't know that, but when I was first building recommendation engine, that's when I realized that recommendation engines are not just a software piece of software. It interacts with people, so you need to know people first to build a system that interfaces with them, right? So thinking further, pretty much I draw that inspiration for that from that book. The book popularized it, but this concept has been around for a while. So thinking fast, that's what I try to mean there. Cool. So what Daniel Kahneman popularized is that among all the other things, there are like how as a human we make a decision, right? There are like ways in which our mind works. How do we, sort of think, right? So he breaks it down into two thinking process. One is system one, which is fast, automatic, intuitive, and emotional thinking, right? That's one system of thinking, right? And then there is a system two thinking, which is slow, deliberate, logic, and effortful. So in any given point in time, whatever the decision you're making, either it falls into one of these two buckets, right? And I mean, if you have realized, so this is a quick example of what is a system one thinking, right? If someone asks you what is 2 plus 2, you don't even think, just say it, like you just throw the answer right away because it's being there, sticking in your brain. You know it very well. It's like there is no effort at all, right? Let's say if I ask you this question, what is 487 multiplied by 151? You can't give me an answer. You have to, I mean, you probably pick a pen or calculator, whatever it is. You have to make that computation, and then only then, right? If you're using some devices, it will be easy. You'll give me the answer quick. But if you're doing it by paper and pen, you might even want to verify it once more just to make sure that the answer is right, right? So that is system two thinking, right? And what recommendation engine tries to do is to bridge a gap between system one thinking and system two thinking, right? We have so many options to choose from, and that got us into this mode of thinking, this system two thinking. You have so many options. Now you feel like this is a problem that you need to solve to get an answer, right? And and that's where all the side effects because comes to the right? And system two thinking is quite intuitive, right? Like this is the gap between two systems, right? That is what a recommendation engine would bridge. Try to make the system two thinking as simple as possible so that you can make it, but still it's not going to make it as simple as system one, but it makes it as simple as possible, right? Clear? So I think you signed up for Tech Talk on recommendation engine and LLM, and then you are talking about psychology, right? It might be counterintuitive, but to get to the bottom of recommendation engine or in pretty much any system that deals with people, right? You really need to know people to build a system that actually talks to people, right? So we'll start with this, right? We set a motivation why we want to build a recommendation engine, because there are decision fatigue in pretty much any platform that you interact, right? And then we understood that the root of the decision fatigue is because whenever you face dilemma, you switch into system two of thinking, which needs a lot of energy to solve the problem, right? Uh, so now we are actually getting into the point, right? What is a recommendation system, right? To just get the basics of recommendation system. So how many of you are aware of search and discovery, work in search and discovery? Anyone? So what is search and discovery, at least, right? At least you would have used some Elasticsearch or something that plugs into your system, gives you full text search. That's like basic search and discovery, right? So there is a difference between search and discovery, but anyone can uh, give me the exact reason. But because they pretty much sound like they are one and the same, but there is a very subtle difference. Anyone want to take a stab at it? Okay. So searches. Okay. You know what you're searching for. Okay. Okay. You happen to find. So there are many ways to say it, but I would like to do it through a riddle. It kind of sticks to the people's mind, so that every time you get a dilemma, what is search and discovery? It's a very subtle difference. This riddle might help you, right? Uh, so if you discover something you did not search, your search is broken, right? You discover something you did not search for, then search is broken. Okay. Still with me? If you find only what you search for, your discovery is broken. Right? Clear? So anybody still not clear? You want an example? Probably I'll give an example, right? So you search for jeans. You go to a online shop and you're searching for a jeans, and let's say the result shows up like this, right? Is it a good search or bad? Is it broken or not? Broken? No, right? So if this shows up in your search, this is broken, right? Because you search for genes, you are consciously making a decision, but the machine is not giving you the right answers you're looking for. This is a broken search. Clear? And you search for genes, and then you liked one of the genes, one of the product, and you clicked on it, and then it takes you to the product page, right? Like where you can sort of buy the product, like you can check out and stuff like that, right? And below that, usually you would find a carousel, right? Which may have other options similar to here, like you have other genes, and then like maybe like you're searching for a jeans, you might as well buy a T-shirt or footwear, right? So this is your discovery, right? The platform is trying to show you something relevant to what you're trying to buy in the recommendation, right? So this is a broken discovery because it doesn't make sense, right? Like the customer is already trying to view a product. Probably the next big thing you can do is like try to give them other options. Now here you are only giving them same options we have. Clear with what is search and discovery, right? So recommendation engines, they pretty much fall under this search and discovery ambit, right? But they are even more than that, right? They follow the category of discovery, but they do more than that, right? When you have a your site, your UI, right? For most of the part, maybe if you have worked in a UI, right, it pretty much your visual design, the interaction design, right, how your site looks like it, how you navigate between that, pretty much it remains the same for most part of the life cycle, right? Maybe once in a 6 month, you might want to refresh your landing page or something, right? Once you design it, pretty much stays for a while. But recommendation system, right? That's your sort of dynamic form of UI, right? Because you can do something in behind the scenes and then give a slightly different user experience to the user through recommendation engine. So recommendation engines are the dynamic part of your user experience. Your visual design and then others are like going to be static for good part of their lifetime. And not only that, most of your platform, right? Like today, when users are inside your site, your platform, you can keep them engaged. But what if they close your app or application and then go away, right? Like you want to re-engage them. That's why a lot of companies they try to engage in the other platforms, the social platforms like your Facebook and then others, so that like they can get you wherever you are. They're gonna have their own presence, and then whenever they get a chance, they try to hook you back and bring you back to their system, right? And that is where recommendation system again helps you, right? There are ways like you can plug into your social platforms, specifically a few things like in-app notification, right? Say like you were trying to order some food and then like you decided you don't want, you're not hungry and then you closed and went away. And then you can figure that out and then you can say send a message like pick up from where you left off. Right? You would have seen this message a lot of time, right? Pick up from where you left off. You abandon the basket, come back and buy something for us. So that's something comes under your recommendation, right? So it's like pulling the customer back into your platform again. Not only that, and also similar to this, right? You would have seen it. It's like if you're trying to buy shoes and you're browsing, and then few days later you will find a email in your inbox that says like, here's a product that's similar to what you like. Right? Again, hook to user to bring them back into the system. Right? So that is where recommendation engine within your UI they are dynamic, and then even user goes out of your system, they still can help you to pull them back into your system and then sort of keep them engaged, right? Okay, so now that why we need recommendation systems. Now let's see what is the recommendation. What is the okay? So for this, there are three P's. Anybody want to take a guess? What are the three P's of recommendation, like types of recommendations? Any guess? No? Let's see. So the one of the P is popular. You would have seen in many like bestsellers, right? Like, and then the personal one. And then so popular is usually it's something that generic to everyone. Okay, everybody is buying this. Do you want to consider buying this? It may not be personal to you, but personal recommendation is something that based on your own history, right? And then placements. Any idea what is placements? Placement is something you may not have heard, but you would have seen it. Any idea? Yeah. So it's basically like advertisement. Like you would have seen, but maybe when I show the slide, you'll understand, right? So these are the three P's of recommendation in different types of recommendations. Let's see what they are in detail. So popular recommendation, right? The all-time popular, like they have no season. These are your best sellers. You go to any platform, they'll say these are the best sellers. Shoes in every category, you'll find a best seller. But it may not suit your need, but it's just a best seller, right? And classic movies, like in movies, you have classic movies that there is no time for these. They never go out of fashion, right? And another one that is trending, right? Suddenly that something picks up and then everybody start buying this stuff. So this is like very short-lived probably, and they suddenly get popular. Like these are like seasonal stuff. Like during Diwali, the things going on and all that, right? During festive times, there is a season for everything, and even for clothing category, there is a season for every type of season. You have different clothing, so they'll promote a different kind of clothing, right? That's a trend. And overnight successful with all the social media, there's like things get blow up immediately, right? Those are the things that comes under your overnight and one hit wonders, right? Those are trending recommendations. Again, these may not be very personal to you, but they do exist for a reason. So cat videos are like all-time favorites. Like there is no season for them, and then like your IPL, right? During IPL, it's a, like the OTT platform start featuring IPL during the seasons, right? Cool. So now we are getting the crux of recommendation, right? The personal ones. So first off, we have collaborative filtering. Any idea what is collaborative filtering, or like you want to take a guess? What is collaboration here is? So basically, collaborative filtering, it is like as it says, collaboration between. You're not exactly collaborating with anyone in any platform, but what it means is like you do certain things in a platform. Let's say you're Netflix and you're watching so and so. You watch certain movies in certain orders, and then there is someone else who is also watching, and Netflix kind of suggests what you are watching to the other person because you both of your interest matches, right? That's collaboration. That's not, you're not exactly collaboration, but from a platform's view, it looks as if these two users have similar journey. Why not suggest something that this user has seen, right? That's collaborative filter. We'll see more detail in detail in the coming slides. So yeah, when users have similar journeys, they get recommended others. And then content-based filtering. So content-based filtering is basically like it's specific to what the item is, right? For instance, if you're watching a lot of horror movies, right, and then some horror movie launched, uh, by virtue of you being what your watch history is dotted with horror movies, they would know that probably you like horror movies, and then they'll suggest horror movies. So it's basically it's not specific to you, but what is in your content, like what your watch history. This is being repeated, so probably this you may watch, right? So that's content based filtering. So product with similar attributes, right? So let's see a little bit on collaborative filtering, how it works, right? So here you see, right, it's a matrix of, let's say, the one on the top is probably like what kind of food you want to feed, right? And on the, on the rows, you have different, I wouldn't say pets, but animals. So what it shows is like, let's say, for instance, cat does not like milk, and then it likes fish, and then and does not like meat, and then eggs and greens, you don't know, but veggies it likes it. Right? And then you have dog, wolf, and fox. Right. The plus indicates that that particular animal likes it. Minus says that this animal does not like it. And then question mark is basically you never tried giving it and they never express their desire. Okay. So collaborative filtering, what it tries to do is try to solve for these question marks. Right. There are certain unknowns and knowns, likes and dislikes. And what we do is like based on their commonality, we try to predict. So let's say if you look at this, right, dog, wolf, and fox, they all like milk, right? That is a commonality. Similarly, you can see eggs, they all like it, right? Another commonality. And then if you look, there is no data for wolf, but again, dog and fox both seems not like fish. Similarly for greens as well. So now, if I want to predict if a dog would like meat or not, what is your guess? Why? Correct. Because there are like there is a collaboration between these animals, right? They are like they're not exactly collaborating, but in a sense you see that okay, they all seem to have similar likes, let me guess, it might like, but this is just a guess, right? So that's pretty much what happens. And similarly, if you go to veggies, again, same, they don't like, and I'm probably guessing veggies don't like. So again, like this is pretty much what collaborative filtering does, right? Let me take a pause. Collaborative filtering is one of the biggest problem with collaborative filtering is the cold start. So what do I mean by cold start, right? If let's say I introduce maybe what is it like otter or something, right? You have no idea. Let's not consider that we have general sense of what is an otter, and otter is in the sea and it probably eats fish and all. Let's say you don't know nothing, right? Because it's not you deciding, it's a recommendation engine that needs to figure out this. So if I introduce otter to this list, it has no likes or dislikes. You can't figure out. So now collaborative filtering is it cannot make a move. So it doesn't work. So that's a cold start problem. In recommendation engine, cold start is a big deal. Like it always happens, right? So collaborative filtering suffers from cold start. So if a new user enters, it may not be able to recommend. And I don't know if you have noticed some platform when you onboard, the moment you log in, they might start asking you, give me, even in Meetup, right? You sign up, right after that, they'll ask you to choose 3 or 4 technologies. Why? Because their recommendation system does not work unless you choose few technologies for them. Otherwise, they cannot suggest what to suggest at all. And similarly, in some other platforms like O'Reilly learning systems as well, right? You go, the first thing they ask is, give me few likes and dislikes, not dislikes, mostly likes, so that they can kickstart their cold start problem, right? So that's why they ask you the interest. So that's one thing about collaborative filtering, and that's how you mitigate a cold start problem. And other problem with collaborative filtering is it doesn't scale really well. Imagine this. This is a matrix, right? Imagine you add a million product, which is easily, I mean, possible today, right? Like in some platforms, we'll have thousands of platforms. For every user, you need to have one more light display. And you have suddenly you overnight you scale, like everybody, thousands of people or millions of people sign up for a platform, and then this explodes. Imagine a matrix of 1 million and million. That's impossible to solve. So, and then there are ways to solve it, but generally speaking, collaborative filtering may not scale really well when either one of the dimension, your product or the user, increases drastically. There are ways to mitigate it. One is to use associative neighbors. Instead of looking at the entire matrix, you'll just look at the smaller chunk of values and then mitigate it. Any questions, if any? Cool. Moving on. Similarly for the cat, there are just like, so coming to content-based filtering. So content-based filtering, it revolves around one thing, that is define a similarity measure for content. Yeah.
So you said about collaborative problem. It is not a solve it to popular recommendation because we don't know what the other person is.
Correct.
But it solve it with analytics.
So yeah, I think the question is like, can we solve collaborative filtering problem with popular? So yes, that is definitely one way to solve it. So those are the few things that definitely, like, one is the asking the interest, and two is the popular recommendation. Usually you see it a lot, like most of the OTT platforms, there's a huge banner that keeps sliding different things, right? Most likely you try to pick up one or the other. So yes, that also helps. But again, you need sufficiently large number of likes before it can kick in. So when we say cold start, it's not like 1 or 2. You need sufficient, depending on the different use cases, which platform it is. Like you need sufficiently large number of likes and dislikes before your recommendation engine can do a slightly better job. Right? Did I answer your question? So content-based filtering. So content-based filtering, as I mentioned before, it is based on what is the content you. It's not about you. It's about what you watching or buying, and then you compare something against. For instance, right, you're trying to buy, let's say, a phone, and then you start getting a recommendation. Okay, here's a what is it, tempered glass for this phone, and then here's a phone cover for this phone. Right, that's content based. It's not about you. It's about this is the phone. You're looking at iPhone. Most of the and here's a cover that fits this iPhone. It's based on content. You're not going to get a random phone cover for iPhone, right? You're going to get phone cover that you can put it on iPhone or temper glass that you can put it on iPhone, right? So that is content based. Whatever you're looking at, you use that information to suggest what product you want. So that's content based filtering. But to get your content based filtering, you need to define your similarity measure for your content because contents change. You might have a numerical content, you might have a text based content, you might have video or image based content. So you want to get your similarity score better, which function that kind of tells okay this and this product they are this similar. So that is the crux of solving your content based filtering. We'll see in a moment. So attribute similarity, this is like your category, genre, color. Based on that, you can use it. And then the vector similarity. That's just pay attention. Vector similarity is something that we dive deep in later section. So vector similarity works on mostly when you have text data. Vector similarity usually works. For instance, right? How many of you know or any of you are like allergic to math or vector or something? No, right? So the vector similarity basically it's like that, right? You have real world objects and you're trying to represent it as a vectors, right? We saw matrix and one row of matrix is your vector. So we try to represent the real world object as a vector, right? I'll tell you why, but so here's a quick example. So you have a X and Y coordinates, and then you have three animals, right? Cat, wolf, and dog. You can see, let's say these are like cat and wolf and dog are positionally placed within this. Just assume that cat, wolf, and dog they are like positionally placed in a three-dimensional space, and then they're how they are how far they are from the origin and how far they are from other animals. That kind of gives you similarity. For instance, if you look at this, right, wolf and dog are slightly related in real world, and then you can see when you get a vector representation of them, they kind of stick together in a similar spatial space, and then you can see the cat is slightly different, it's slightly off. I'll give you an example. I know it's difficult to right? Let's say we want to make some tea, right? Sorry. So let's say we want to make a tea, right? So I don't know if I can serve every kind of tea, but let's say. So you have options like black tea is regular brown color tea, and then you have green tea, and then like you have water, milk, sugar, and ginger. So these are your ingredients, right? And then I want a black tea. So black tea, you need a black tea, obviously, and then water, boiled water, and then add sugar, and then you get a black tea, right? Makes sense? And then you want a milk tea, you add a milk, you get a milk, right? And then goes green tea, ginger milk tea, right? So if you look at it, right, it's basically so minus represents no, X represents presence of it. But this isn't enough, right, for us. We want more options, right? Obviously. So strong milk tea, no sugar, right? So now you can't just say yes or no. It's not a presence or absence of it. You have to start putting in numbers, right? So strong black tea. So I'm giving. So it's like, let's say this is volumetric. If you add all of them, they should get around 1, but it's 1.1. Sorry, that should have been this should have been 1, right? So it basically represents what is a volumetric value of this particular ingredient in that thing, right? And then light milk tea with half sugar, uh, and it goes on. I mean, always green tea is easy. There's a lot of options, right? How about this, right? So what does this even mean, right? You look at it, these are all the different, what you say, is a different option that you have. And then if you mix them in a certain, proportion, you get your desired effect, right? So these are dimensions, the black tea, water, milk, sugar, they're all dimensions of your values. And then there's the magnitude, and to what, like, you have dimension, and within that you have a knob, like how much you want that, right? And together you have a vector form. So basically you can represent every as a vector, right? Got it? This is the best, simplest example I could find. I don't know if it worked, yes or no. Thank you. It was really difficult to get it to that level. Thank you. Right. Why not? How about this, right? Like, you guys have to help me with this. I don't know how to solve this one. Steaming Darjeeling tea served with a fine china cup tea with a delicate floral patterns, accompanied by assortment of dainty finger sandwich and a freshly baked scone to rest in a basket, ready to be topped with clotted ice, clotted cream, and vibrant strawberry jam. So, how do you how do how do you get a better representation of this? I don't know. I don't know about you guys. The clotted cream is something new. Maybe to be honest, I generated this with ChatGPT. Okay, so so I asked ChatGPT to give me a good description of English high tea, and then he got it. So how do we go about, vectorizing this? Previously, we had few options, so it's easy. You can just use volumetric method to, come up with a thing. But this is like verbose as much as you can. So if you squint your eyes and look at it, right, that's all there is. Tea, sandwich, scones, cream, and jam. That's all there is. But everything else is, sort of adjective, kind of make you crave for it. Right? So yeah, so that's about high tea. So how do we, sort of vectorize this? Right? This is real world. Previously, what you saw is just a simple example, but this is real world example. Right? Things can get as complicated as this. All right, that's where we have embedding. So how many of you, please show your hands if you have heard about embeddings before? Okay. I mean, if you raise your hand, I can, kind of dial it down a bit if you don't, right? So at least, okay. How many of you heard about ChatGPT? Okay, good, fine. And OpenAI, good. And do you know what is their recent model that they released? Recent model. 4.0 is Omni, right? So ever wonder how they work internally? Like, try to figure out how they like do those stuff, right? So internally, right, computers don't understand a bit of when I say language, natural language is a text, right? They don't understand your language, whatever you speak, they're gibberish to you. Whether you speak in English, Tamil, or Chinese, they can't comprehend it. How do they comprehend it? Because they can only work with numbers. Numbers is all they can crunch. That's all they do underneath. And everything that every text needs to be sort of converted into some sort of number so that they can work with, right? That's what pretty much the answer to your previous question as well. Say like the example that we use, right? Like the streaming Guardian theme sort of thing. So in you could use OpenAI. OpenAI, they also sell API, so you can pay some money and then you can use their API. I mean, ChatGPT is free, but if you are using their API to make direct calls, you have to pay. It doesn't cost much. So you could use their embedding models. Embeddings are like what converts your natural language, your text, into numerical values that computers can process further, right? So every time you key in something, type something in ChatGPT, it goes there, it gets converted into embedding, right? Similar to embeddings are basically vectors like the one that we saw before, right? But they are not few hundred. They are like, to be precise, it's 1,500, like 1,500 numbers that represents a vector. So every time you ask something, ChatGPT converts it into vector. Only then it processes it, and then it again emits, vector that gets converted into token. Right? So that's how they work internally. So like to answer the question, how do you get a representation, vector representation for this verbose, text? What you could do is you can just do this. This is the code. Pretty much, you can call OpenAI and then say embeddings. I want embedding for this text, and this is a model. They have a lot of models to choose from. So I've chosen the text embedding 3 small. That's one of the 3 embedding models they have offer. Uh, so and then that prints it gives you embedding. The embedding looks something like this, but it's very long. If you see the dimension of ChatGPT API is like 1536. So every time you type something, it's not looking at your text. Instead, it's looking at a dimension like a vector that is 1536 numerical values. So that's how it works. Uh, Many questions so far, and I know it got a little that's yes. That is how big the yes, yes. Okay, it's a little advanced, but when you have so usually there is a chunking. There is a concept called chunking. So if you have a very large text, what they do is chunk it into a smaller text, and then get the embedding. Usually that is 1,000. So regardless of your text size, it always gets you get a constant vector. Cool. Any other question? All right. So, okay, so far we have seen popular recommendation, which is your all-time popular, and then trending, and then we saw personalized. That's where we saw collaborative filtering and the content-based filtering, and the content-based filtering we looked into what is vectors and others, right? And then here's the third piece, the placement, right? So you would have seen the placements, right? Usually they promote, right? Whenever in OTT platform they launch a new, movie or series, they put it up in the hero banner, and then it always there for you to watch, right? So that is basically placement. Um, and usually that is for a demand generation purpose, like someone mentioned, right? Like it can be used to alleviate your cold start problem, because you add a new content to your platform and nobody's looking at it, it never gets consumed. So placement is one way where you can insert a new item into your user's perspective and then start consuming them, probably prompt them to consume them, right? Um, and then there is another one that is sponsored. May not have seen it a lot in OTT platform, but in a lot of retail shops, you would have, like if you are searching for a phone, you are looking at it, and then there are other phones. It says sponsored. Maybe I think I have a. So right. Let's say this is Netflix, right? And then there is a new season of Money Heist is there. They'll put it in the hero banner. So that's your promotion, right? Um, and then sponsored is like I'm searching, I'm trying to buy a headphone, and then I'm searching in Amazon, and then you would have seen this, right? There is a little icon that says sponsored. It's very little so that you don't realize it, but most of the time this generates ad revenue for the retailer. This is one way they monetize, right? So these are the two types of placements. One is for demand generation, other for sponsored. But in a way, if you think about it, right, pretty much every advertisement platform it's kind of a recommendation engine, and for most of the time, the search and discovery is like a mouthpiece for any sort of advertisement. Even for Google, right, you're trying to search, and Google uses that search to insert their advertisement into the feed. So a lot of times you will find search and discovery platforms to be monetized through placements, because nobody likes advertisement, and what is worst is like advertisement doesn't even it's not relevant to you, right? So where do you place a relevant ads is when you are actually looking for certain things, and then okay, this person is looking at this, probably there's a similar item that someone is ready to pay me so that I can place it right there. They probably click and buy. Right? So that is sponsored placements. All right. I think we have covered a lot of ground so far. We saw what is search and discovery and recommendation systems are part of that. And then we saw how recommendation engines are dynamic form of your user experience where you can dynamically change stuff. And then we saw user engagement beyond platform. When your user goes out of your platform, you can still try to send a hook that is relevant to them so they can come back to you, right? All right. And then we saw what's the types of recommendation engine, and then there's a popular, personal, and then basics. And specifically, we saw content filtering with vector similarity. I'm stressing on this bit because the further in the talk we will, further explore on the content-based filtering. All right. So now we have seen why, what, and then now we are trying to see how. So how do you approach, right? Like so far, we got the motivation to build the recommendation engine, and then we got the tools like your collaborative filtering, and then your content-based filtering. Those are tools, and then how to place them. That's your placements and personalize and then popular. So that to place them, and then how do you approach, right? You have all the tools, you know the motivation. How do you solve it? You're staring at a problem that needs to build a recommendation engine. What is your thought process? What is your solver's mind, right? For this, I find this diagram represents it better. So always you start with the candidates. There is always some candidate, like you have a list of movies to recommend or list of items to recommend, etc. Right? So you have a candidate item which needs to be recommended. So always think of this recommendation as a funnel, because you have, when you start, you have thousands of products to recommend, right? And then you want to push it down this funnel till you get fewer options so that like people can actually look at it. Right? The first step in that is retrieval. So you have thousands of products, and then first thing you do is retrieval. We'll come to that a bit. And then you further push it down low. Let's say you've gone from 10,000 to 1,000, right? And then you rank this 1,000 products, right? And finally you get top K. Usually the top K is the industry term. That K might change based on your use case. Let's say you're looking at a small window. It mostly depends on what is your real estate there. Maybe if you've seen in Netflix, the carousel moves on, right? Like you can go all the way to the right and left, so you can have 10, 20. But if you look in Amazon, right, you're looking at a product page, you can say 4 at a time. So depending on the real estate, the top K changes. So it's very platform and problem specific, but usually 4 or 5 we take. So we retrieve the candidate, we retrieve small set of candidates from the larger items we have, and then we further rank it, and then we take the top K, right? So this is pretty much what a recommendation funnel looks like. The way to think of this is like the first thing, the retrieval is more like an elimination, a step. Let's say you go and in Amazon you search for Android phone, right? What is the easiest elimination you can do there? You're searching for Android phone. Any guess? Very simple. Remove iPhone. That's all. Right? If you're searching for iPhone, it's very easy. But Android still. But if you're searching for Android, like still there's quite a bit of thing that you go through. But at least you got rid of something, right? And not only that, usually if you're searching for phone, I can also, when I say items, it's everything on Amazon, right? Even in a shorts, a t-shirt, or jeans, you're removing that as well. You have millions of catalog. So when you search for phone, there are Android phone, there are two things. One, Android, remove iPhone. Phone, remove every other category, books, chocolate, whatever. So that removes that's basically your elimination in retrieval. So in elimination, you are not doing anything specific to the user. You're just trying to make your own life easier, right? By removing two. And then there is rank. Now you have Android phone. Now you have usually what you see is like mostly you see like top 4 or 5 will be sponsored, and then you have some sort of rank, right? And then you could, if you made a even more deliberate search like Samsung Galaxy, then instead you would see a list of, maybe you will start with Samsung Galaxy and then it goes around with other Samsung phones, right? That's what you see. So that is basically your ranking, right? So based on your query, it might rank. So that's basically ranking. So when you rank, you're ranking on certain aspects so that only top things are shown, and then out of that ranked list of things, you pick up top K and display your user. I'll stop for a moment, just have a look at it. This is most important slide in this entire talk. So this is all it matters. If you want to build a recommendation engine, look at it as a funnel. You're pushing it through. You have towards the end, you should have only n number of items, and do that through elimination and selection. Right? Any questions so far? Cool. Moving on. Let's try to build a simple recommendation system. A smartphone recommender. Smartphones are like one of the biggest categories. Under consumer electronics, about 30% of is smartphones. It's pretty because like if you're trying to build something, there should be a economical value for it. You cannot just build random stuff for teachers and all, like they don't add a lot of value to it, right? So we're trying to pick reasonably good category which has good market, command. All right, so this is you or maybe me, and you go like, okay, I need a new phone, and then what are the options you have? Ask a friend, or maybe check YouTube reviews, or user reviews. That's pretty much you could do. Um, do you see a problem here? You want to buy a phone, but these are the options. Is there anything else you have other than this? Like you want to decide on that? There is a problem in this. Can you
Bias.
bias? Yes, you're biased by who you choose to follow. Right?
Local.
Sorry, what is it?
Local.
Okay, okay.
Fanboy.
What is it?
Fanboys.
Fanboy. Yes, of course, there are fanboys. So one problem here is pretty much all of these things, interactions or decision happens outside of the platform. What do we do if you want to buy a phone? You don't go to Amazon. You do the research outside of Amazon and then or Flipkart. And then when you like figure out this is what I want to buy, and then only then you go to the platform which sells it, which is kind of anti-pattern, right? You're selling something, but people are not coming to you to make the decision. It's like you want to buy a car, like you don't go to a car dealer, you decide and then go to them. I want this. That's all, right? So it's a good problem to have for platform, and I'm sorry, good problem to solve for a platform, right? I go to this platform, I can decide what I want to buy. I get all the information. I can also buy. Right? That's a great problem to solve. That's pretty much I try to solve. Let's say, cool. The problem, the much of the decision happens outside of the platform that is selling the actual product, right? Cool. Let's try to do the same thing. What we try to So from here, we'll go to code a bit. Um, so I want you guys to rate your confidence on your language preference, so that I can, like, based on that, the next step is mostly code. So I want you to tell me, like, what is your comfort level with using APIs or using Python, etc. How many of you are comfortable with Python? Like, I mean, you don't have to be expert, but you see a Python code and then you can guess what is happening, right? Cool. So that's what we'll be using. Have you used, let's say, making API calls and etc. Right? Like, so mostly we'll be using OpenAI APIs. I'm not running anything locally. Right. Let's move. Let me check it. Next slide. So the first thing is faceted search. Anyone heard of what is faceted search? But I bet you, if I show the image, you will know, instantly recognize what is it. You recognize this, right? So these are all facets to a product. Like if you're buying T-shirt, like there are like colors and size. Those are all facets. So every product will have a facets. Why facets are important is because if you're searching for a text, it's easy. Like you can search a text with a search text, but you're trying to search a product, and product has certain attributes, right? And if you give certain, clear instruction like I want so and so GB and above, and then phone premium camera resolution has to be this. If you give this specific information, it's a lot easier to retrieve the right product for you. So what usually, retail platform do is when they get a product onboarded, they kind of retrieve these facets. Usually, what the way it looks is like if you're a seller, you have to give all these facets. Okay, this is the memory, this is the RAM. That'll be a what do you say, sort of a form which you fill in when you onboard a product, and then that gets ingested, and then sort of available to you when you're actually trying to go and search through. Okay, so facets are a great way to do the retrieval part. Remember I said, right? Like first thing is retrieval. Retrieval is the important step because how well you do the retrieval makes your life a lot easier when you're doing the ranking because ranking is really hard. I mean, honestly, it's very hard to do a rank, but if you do retrieval really well, it's not that you can do retrieval well. You have to let people do the retrieval better, right? If you give these kind of facets, people can choose, I want 6 GB RAM, which makes your life a lot easier because that excludes a bulk of the product away from your ranking task, right? So the more option you give as a facets, it's easier. User can choose it, and then it makes your life easy when actually going to the ranking task. Clear, right? Cool. So these are the facets. What you're trying to solve is right. The one of the problem in getting these facets is imagine this, right? If you're talking about smartphone, there are like probably thousands of smartphones, and then smartphones are sold by proper companies, and then they usually give you good data quality, right? Because mostly when you're selling products, especially marketplaces, right? Do you know what is a marketplace is? Marketplace is something you create a platform where others come and sell you, like Amazon or Swiggy is the marketplace. The problem with this marketplace model is that who are you getting onboarded, they have to give you really good data. Otherwise, all your system, recommendation system, everything's screwed. But there's only so much you can force them to give the recommendation good data. You have to do some heavy lifting here and there, right? So that's the main problem there. So with the cell phone data, it's a lot easier because there are only vetted vendors who can sell these kind of items. They are high value items. You should not just randomly go and start selling phones on Amazon. They will vet you and then only then they'll let you sell it. But if you look at the other miscellaneous categories, right, you can sell t-shirts and those things. You don't know who is listing those products, and they may not even sort of give the proper attributes of the product, which makes their life hard, and because their product may not sell really well because it's not getting discovered really well in the platform. And also it's make the retailer's life difficult because they couldn't properly index this product so that they can bubble it up and show it to the user. That's another issue. So data quality is a really huge task in kind of getting this faces. That's a problem. So faces on the face of it is very easy, but getting this faces data, right? Yeah, pulling out the attributes from product information, that's a hard part. Are we clear with the motivation, right? Facets are a great way to help your retrieval task. They they kind of eliminate a lot of stuff, and they're hard to get the facets because data quality. Yeah. All right. I think beyond this, yeah, I have one more slide that shows you. So you have data coming in through your product, different product data, and then you extract the features. These are the facets. What is your RAM? What is your storage? What is your processor, etc. Color. And then you build something called inverted index. That's a new term again. Any idea what is an inverted index?
Elasticsearch stores data in
Correct, correct. Uh, any idea how it is different from the regular index?
an example if there is a cookbook for
Okay.
so I want to search where a chocolate cake recipe is.
Okay.
The search engine won't be searching for chocolate cake word, the text in every page.
Every page.
Before storing, it will search for the particular text and store the chocolate cake word it will only be 10th and 30th page. So while the user searches for it, it will be only going and search in 10th and 30th page. So it will be more faster than normal indexing.
Correct. That's pretty much it. Just to iterate on that. So let's say when you add a product to a table, right? Like something, you give it an index which is like 1, 2, 3 or something, right? Or GUID or something. Index, and then you have some details. Right? That's index. Your regular index. Inverted index are like you have attributes. Let's say for instance what you said, right? You have a cookbook, and then every page is one record in your table, right? And it may have chocolate cake or it may have chocolate fudge. What you do is you have maybe a book table, something like that, and then which has maybe every page is going to be a separate record. In addition to that, when you're ingesting this data, what you do is you ingest this data and then pick up these keywords and then have a separate sort of table which says chocolate, and then it says it will have a list of document IDs which has these keyword in it. So when you search for chocolate, it will go to the inverted index and then finds list of pages that has this word, and then it goes and fetches those those columns. Otherwise, you would end up doing a full text search on the entire data, which is computationally intensive. You cannot scale a system like that. So inverted index are great for search and retrieval. So that's what inverted index is. So you build the inverted index during ingestion process. You don't have to rebuild it unless the data has changed. Clear? Any question on inverted index? Cool. And then once you build the inverted index, let's say I'm going to say, I want my phone that has 6 GB of 6 GB of RAM, right? And then what you do is you go and pull all the inverted index and then get the product details for all the products that have 6 GB of RAM. So that way it makes your life a lot easier, right? So that's about basic research. So this is the kind of stuff we try to see in the code, right? All right. Yeah. Cool. I'll switch to code, and I would have to stop the video so that my code is visible on. Right. So okay. So I was talking about this embeddings. Um, please. Yeah. Cool. So we just so this is the one that I was talking about, right? Getting the embeddings from OpenAI, initializing my code. So what I have here is I've given the model name, which is text embedding please mod. That's a model name that you want to use. And then this is text. You remember the text for which we wanted the embedding. So what I'm making here is I'm using OpenAI's API. I'm giving this is the input text, and here's the model. Use this model. Give me the response of the embedding. So if you run this, it prints the link. Let me print the embedding. So this is pretty much it. So for this text, right, the one that we saw in the example, this is the vector representation of that text. Cool. No, it's for the entire document. Oh no, I think no, it's so what it does is, so you get a document token. It's not like in a sentence. Sorry, repeat that question. No, you get a vector representation of the entire document. Not exactly. You can tokenize it for every single things, but what you're getting is here document embedding for the entire document. So if you look at the data, right, it gives you just one embedding. You tokenize it, and then you get the embedding for the entire. Yeah. So I think it's a list. So response is a data, right? And if it's a list, right? So if you check the length, so one length. So it's a document vector. One document.
That's how not the family code, right?
Yeah. Okay. No, this is a document vector. Okay. So yeah. So moving on. Right. So I have some few things imported here. So we're going to use something called LangChain. So OpenAI gives you all the elemental stuff like your embeddings and then helping you, do the different models that can actually, do chat completion or even insect models. But they don't give you like sort of applications. It's like OpenAI is like AWS, but for AI backends. They are not actually giving you any particular application. I mean, of course, ChatGPT is one of the application, but you can leverage their models and build on top of that, right? So for what LangChain does is gives you some additional stuff which you can use to build slightly more advanced stuff on top of the OpenAI's tool. So if you want to know about LangChain or even uh, embedding or even OpenAI stuff, there are really good sources in deep learning.ai. They also give you hands-on practices where you can actually practice stuff. So for this, I'm just using GPT-3 Turbo and then I'm setting temperature to 0. So temperature is basically how creative your model gets, like how variation your model gives. That's what it is. So I have a data here. So basically, what it has is a description of phones. It's a text file which with one line for every phone, and then it has some description. Quickly initialize my things. These are just standard, utility methods. So I'm loading my description, right? Let's say it says load a 9 description. Let's quickly see what description has, right? So this is one example. So we are looking at a imaginary cell phone's description. It says discover the galaxy beam in worldwide with 12 GB of RAM, 52 GB of internal storage, equipped with so and so processor, GPU, like this is like sample marketing introduction sort of thing. So you have similarly you have like 9 such description of phones. This is just a toy data. It's not like actual data from any of the retailers. So and also this 9 out of this 9 there are like you have variations. There are some smartphones and high-end smartphones that has 6 GB or 12 GB RAMs, and there are mid-range smartphones, and then there is a feature phone. So I have some variations of different phones here, right? You're clear what is the data here, right? We have description of smartphones. And how many of you aware of prompt engineering? Have you tried prompt engineering? Raise of hands. So what do we have here is a simple prompt template. So prompts are things that you basically are talking to an AI model. You want to tell what it needs to do and how it needs to do, and how do you expect it to spit out the your data, right? So this is a simple prompt. It says you are an AI assistant tasked with extracting important facets of a product from a description, and description of product is enclosed within this triple text, and it says extract the following facets, and then this is basically a template. I can put any facets into it. And then here is the description. And then I can again plug in any description into it. Out of 9, I can plug in any one. And at the end, I also I can instruct it how it should spit out the the response. Because if you have to be very careful with LLMs. You want to tell it like a kid that you want to instruct it properly so that it will give you the right answer. So if you look at it, right, it's very generic. It's not specific to cell phone or anything, just simple. You can insert any facet, right? Let's say tomorrow you want to you want to do extract the facets for maybe a washing machine or AC. You can say, okay, for a washing machine, tell me whether it's a top load or front load. Tell me whether it has hot water facility or something. So the facets, you can plug in any facets based on your product category. So that is templatized. And then again, description of the product that you plug in there. And then the instruction of how it should give the result, it pretty much remains the same. It's basically a JSON format. Clear with this? Any question on this? Right. So this is basically a template. Basically, you're like you're writing an instruction for computer to give you the right answer. Yes.
So we're trying to do the heavy lifting here, right? For example, because all the products are not, they don't offer good data, so we're trying to extract the faces out of them.
Correct.
That will be,
Correct. Correct. Yes. You were saying something? Okay. So yeah, that's pretty much correct. So we have data quality issue and we are using ChatGPT. In a moment, I'll tell you why that is important. So we're just doing some. So what it does is basically it takes the description and then the template and then output parser, and then it sort of stitches all the text together, and then it gets you the full prompt, and then it fires the chat, which is like it fires the data to OpenAI, and it also gets the result back and it gives you that. I can show you the prompt. Yes, sure. So for the response, right, like I mentioned, right, you are giving information to the OpenAI, and then it's going to return you some information, and you should be in a position to parse it out because it's going to give you the text output. You need to extract. There is the extraction step involved in it. So for that, in LangChain, there is a way you can define it. So you say like, okay, response schema, processor, and then you give a description of the process. This is very important as well, right? The description is not just says like processor of a phone. it says further, right? It's like very detailed instruction, right? It says if not available, mention unknown. Like you have to say it's like exception catching in your code, right? You handle a scenario. What happens if it doesn't exist? You have to catch and then you do something else because otherwise it will give you some random input. So you have to give it specific instruction that if this processor name does not exist, give me a response unknown so that you can process it further down your pipeline, right? And then you're also instructing it what is the expected data type, it's a string. Similarly for others, right? Uh, this one is also important, right? Let's say RAM of a phone, right? As expressed as an integer and in GB, right? You have to be very, when you're using any specific units, right? Like your GB, like when you have like RAM that is usually expressed in GBs, or anything that has certain unit of measure, like your screen size, it might be in inches. Let's say some manufacturer has given the screen size in centimeters, right? And someone might have given it in inches. If you don't give this specific instruction, it will just give you the number. You don't know whether it's inches or centimeters. So, but in your prompt, you mentioned that give it in centimeters, even if it is in inches or whatever it is meters, it will convert it into that unit so that your data is uniform across the board. Clear, right? So these are very small nuances that you have to be very careful when you're dealing with it. And similarly, right, I'm also giving a exception value. When this does not exist, give me -1, so that like I can process it down the line. Yeah, and then type what else? Cool. So this is what the structure of output I'm expecting. So result. What? So you wanted to know the prompt. Let me run this. So to run, I'll run it in a try mode. Right. So I don't know if it is visible. So this is our entire prompt. So URNA stand so and so blah blah blah. Extract the following facets, right? You see, this is the this is something that you inserted. You have a template and then you inserted what are the facets you want to extract. Uh, and then this is the description of the product that we again plugged in. Output should be markdown code snippet. You expect it to give the result in this fashion so that it's easy for you to process it further, right? So this is the entire prompt. You could, in theory, just copy this and paste it in ChatGPT and it will do the job, right? But we're going to use APIs to make the call. So this I'll not run in try mode. If I run it, it's going to make the call. It's going to build the template and fire it to the ChatGPT. Right. So here you see this is the description. Yeah, fill the description. So this is the description of the product, and with this you got a nicely extracted facets of this product, right? Yeah. So further down, what you can do is beyond this, it's a matter of building your inverted search and then querying it, which is standard process. What I wanted to focus on is like even if you have really bad data, you could actually fix it. What I'll do is maybe we'll try to see how things work, right? I'll copy the whole thing again. I'll create a new. I'll show you how you are mitigating different data quality issues here. So what I'll do is I'll change this to this to 1 TB, right? So if you look at the storage spec, right here, the prompt says expressed as GB, right? But in the description, I'm going to give it as terabytes. Let's see if OpenAI can decode this 1 TB into GB, right? So what you're expecting in your output is instead of it should be something like the storage should be 1424 GBs, right? Let's plug this new description inside. Your facet prompt is going to be the same. You're trying to extract the same facets, and then the output process is again same. Let's run it again. So you see, there is one mistake though. It says 1000. So there's two things. One is GIB and then GB. Let's probably say if let's say if I expect it to give me 1024, you have to work on your prompts better. So storage expect if not as mentioned 1 sorry 1 1 TB. Right. To give extra information, let's try if it works, right? Maybe the cases. So let's dry run it again just to see whether we have the instruction, right? So we have the instruction in here as well. Let's see if the product, let's see if the data is properly extracted this time. Right. So previously it was assuming it to be, I mean, there's a two different things, GIB and GB. So when you give it a proper instruction that 1 terabyte is this many GB, now it's corrected itself. So that's why the prompt engineering is a bit tricky to master it. You need to try a lot of time before you get it right. So you have to give all the minute details so that it doesn't make any mistake, and it's hard to figure out if it makes any mistakes, right? Any questions so far? Cool. So I'm running it on the entire batch, and what I'm getting is, so this all the 9 batches, right? So I'm running it through the API, and then it's giving me all the facets of each and every description. And you see there are some unknowns because these are like 2 GB RAM. They don't have any GPUs in them, right? Cool. I'm going to dump this data because our next task requires this, right? Cool. Quickly go to the. So the next what we're going to do is rank and filter. So we have extracted the facets. So now you can easily use give this option to the user so they can use the facets to make your retrieval task a lot easier, right? Now your product is reduced from 10,000 to 1,000, right? Next up, I'll quickly go through this. I see that's taken quite some time. Sorry for that. Okay, I'll quickly go over this. Okay, I'll make it quick. So on the second one, what you're trying to do is quickly do the same things. So on this, we are using another component called ChromaDB. It's a vector database. Any idea what is a vector database? Anyone heard of it? No? Probably that's a topic for another day, I guess. So we'll talk about, just think about it, right? It's a database, but instead of your primary keys, it has vector, like these are the vectors, right? Instead of primary keys, it has vectors. You search by vector. You give it a vector, and then it tries to find all the similar vectors, and then gives a document. But here's a different thing, right? You don't get one, you give something, it's not like one-to-one mapping here. It's a similarity search. It's not a like deterministic search. You give the, ID1, you get ID1. It's not like here's a T, and then you get all the T text. You give a vector of a T, and then you get all the T text. So it's like similarity search, not a deterministic one. It's more like probabilistic search. Yeah, basic stuff. Yeah, loading some things. I'm just loading the data that we previously, created in the previous notebook. So here what we're trying to do is we're trying to push these data into a vector database, right? Vector database has three things to it. One is your text as such, the text that you want to store. What it does is it takes this text and then it creates an embedding and uses that embedding as a sort of primary key, right? Okay. And then in addition to that, you can have some metadata. Why it is needed is like you're going to do a similarity search. Sometimes, if you know for a fact, there are some additional data which you can use to filter. For instance, your facets, right? You can pass them as an additional metadata. So you can also filter based on your metadata plus the similarity search. Am I making sense? It's getting too difficult to understand. No. Okay. So here's so you remember the vector we got it right for the text. What we're trying to do is we're trying to insert a text into this vector DB, right? Or normally what you do, you insert a text, you add it as a blob, and then you create an incremental index or something, right? That's what is different here. Instead of some incremental index, what it does is it uses the embedding to get a embedding for this text that you're trying to insert, uses that vector as its index, primary index sort of thing, right? And what you do is when you query whatever the query you're sending it, right? Let's say you say give me a recipe for ginger lemon tea, something like that. That query itself gets embedded. You get an embedding of that query and use that embedding to search against this database. So you have a text in that gets creates an embedding and then you save it as with an embedding as a primary key sort of thing. And then when you make a query, again you get an embedding for that query, and then you search embedding to embedding. Yeah. Maybe another talk we can talk in detail about vector databases. So that's what we're trying to do. I'm giving the description, all the 9 description, and then the facets that we recently extracted in the previous step, right? All the facets. One thing I'm additionally doing is just adding the indexes as an ID to the metadata. So if I want to get me the first phone, I can also use metadata search to pull the first thing. And also IDs, again, this is important. If you want to update that particular embedding, you need ID to access and update it. Okay. Clear so far? Let's make it quick. It's ingesting. It ingested close to 9 documents. Right. So here we're going to do a similarity search. There are multiple ways to do a similarity search. Remember, in the content-based filtering, I said like getting your similarity search right is very important when you're doing content-based filtering. There are different similarity searches, cosine, Jacquard, and then maximal margin, and there's a different variety of it. Let's not get into that, but right now we are going to do a simple similarity search. So what you're going to do is we're going to do a similarity search. So what happens is like when you do a similarity search with a filter, you get the same phone, like searching similar phones, that is searching for that's similar to the current phone that you're viewing. you'll also get the same phone from the database because that is also ingested there. So what I'm doing right here is I'm negating that, removing that phone from the search result because you don't want to recommend the same phone they are viewing. Like that's one thing that I've changed. Remember I mentioned the top K, that is the parameter here. So usually it's about your preference, how much of top n number you want. Here we are going with 3, right? And then the filter is basically the negating your IDs. Cool. So what happens is, so assume this, right? You are looking at one phone, and then what you want to do is find all the other phones that is similar to this one, right? So that's what I'm pretty much doing here, right? I pass the ID of the description. So here in the similarity search, I am passing the query as descriptions of that product ID. So whatever the particular phone's query goes in as a search. What Chroma does is creates embedding of this description and searches it against all the other description that is in the database and removes the one that is already being searched. If you see, let me also print the actual description for the reference, right? So discover Galaxy B white with 12 GB of RAM, 512 GB of internal storage equipped with so and so processor and GPU, etc. Right? That's all that is. And the relevant phone for me is something on the similar line, right? 10 GB of RAM, 56 GB, 12 GB. That's pretty much in line with your recommendation. I do see the last one bit screwed up a bit. What is it? 5-inch. That's a feature phone. 16 almost. So I think we also had some features phones in our list. The first two things looks good, but I think the last one is not the one that I expect to. But there are different strategies to overcome this stuff. Right? Clear so far what we did? Any question?
We are using LLM here for which are asking we are trying to extract the structure based.
So the first phase, what we did is we are ingesting the product. So when the product comes into your platform, you are extracting the facets, you're keeping the facets, and when the user comes in, they would select different phones, and then they would like see a particular phone, right? Like assume that you're a user, you're looking at a phone. What you want to do is under the phone, you want to do the recommendation carousel, where you want to put some phones that are similar to the one that user is looking at. Clear?
What exactly LLM solves?
So here what it solves is like, let's assume, right? So you are looking at the product 0, 1, the product ID 1. And what it's trying to do is it's trying to get the search through. So the LLM here, the LLM part is getting your embeddings right.
Like don't leave the OpenAI embeddings to other centers.
Definitely, yes.
What I'm trying to that is the only point. Embedding
Yeah, that is right. Like you can use any embedding. What I'm trying to use is like one that is best available to us. That's the reason why I'm using OpenAI. But you can use any embedding that is for that you can do.
I can see a prompt over there.
Correct. Correct.
That we are trying to extract the structure basic.
Correct. So you want your product to be remember there are 2 steps, right? One is retrieval step. For retrieval step, you want to make it easy for users to give you some signals like I want X number of GBs of RAM, etc. So you're negating good bulk of your products that is not that you don't want to search through. One thing that I could have done here is, let's say the product, we are looking at a certain product and then it has certain number of GB of RAM or something, right? You could pass this as, because right now I don't have a lot of very long list of products. It's just 9. But if you're actually you have thousands of products, what you could do is you could also get the facets of the current product that's being viewed, right? Again, and you can pass it as a metadata search. Okay, so what it does is it reduces your product search from 1,000 to few hundred because those are the ones that has certain GB of RAM. And then you can further do search based on what are the technology, right? Like there's the description, battery, like that could be other things, right? Like it's being used for gaming or it's entry level, etc. Those are the things that for which we need embedding to give us the right similarity search. This one, I can show you.
Understand. This LLM exactly sounds here like unstructured text sets, numbers present. So that you have already stored presence, you will get a similar presence.
Correct, correct. Because it's mostly, I mean, here it looks very simple, but if you really look at the retailer's perspective, right, it's very difficult to get these things right.
I just want to check what.
Okay. For instance, there are other applied things here. Right? I don't know if you have seen, usually, like I mentioned, right, there is something called product onboarding when you onboard a product. Usually, if you have seen the current readers, they have a standard set of form elements. What is the size, what is the color, etc. But it's not, the products are always evolving. Right? Let's say, for instance, you're trying to upload a product that is sports, like maybe was a exercise, a t-shirt for exercise, like gym suit or something like that, right? And you put a description and then you enable things. What you could do is like you have a prompt that says like usually if it is a gym wear, usually people would like to know if it is a dry fit or not, like things that get you can the price quickly, right? You could have a prompt template that says right, you plug in this, try to find if this product is a dry fit or not, right? And then the LLM will execute and tell you yes, it's not. The thing here is, if you have to put this in a onboarding page, you want a developer to create that page and then you have to write code and the whole process. But if it is a prompt, right? In every retailer they have something called product team or cataloging team. They are the experts in particular catalogs, so they can write these prompts for you. And as a developer, all you have to do is just take this prompt, put the data in, and then execute it, and then see whether this has a result or not. And then based on that, you can make a further decision. So those are the data quality issues that you can overcome. Okay. Yeah, that's pretty much what I had for today. Yeah, for a bit of time.
So when I can comparing the finally with GromaDB, that is comparing the description with the other products.
Correct.
To figure it out. Now, is it using again, there is OpenAI to understand what the description is, or nobody can do that for us?
So it's a two-step process, right? When I'm ingesting, like when I'm inserting the description into the GromaDB, every time, so remember this, every time you insert or every time you retrieve, you have to get the embedding, unless you have done some caching or something. That's when so converting a text to an embedding is when you have to make those calls. So when I ingest, I have to make n number of ingestion calls so that I get the embedding and then insert it into GromaDB. Every time I query, I need to convert the text to a vector form so I can do a similarity search. Then I have to make a
So, so every product here also we get the JSON data out of it, or the basic side of it. Every we are getting one separate API call, right?
Correct, yes.
So can you see like rough estimate how? What is the billing like on that? Because so many API calls if you.
I think I added $10. I think yeah, $10. I haven't spent more than $1 so far. It's actually cheap. It's at least when you use GPT 3. I'm sticking to 3.5 Turbo. If you upgrade to Omni, that you can sink a lot of money, but it depends on that. It's not much. So far, what I've seen, at least with the earlier models, if you use older model, it didn't, the whole example, maybe I would have run it just like 10, 20 times. Maybe that costed me few cents, maximum 5 cents. That's all I say.
What as you mentioned, like every product is keep on evolving, right? So can we have a way that we expand these spaces because these spaces are already determined by the like subject matter,
Correct.
right?
Cataloging team.
Cataloging team, right? So can we have GPT or anything help out to list all these spaces over the top so that because every time we have to reach out to them.
Correct.
Can we do that kind of?
No, think about it like this, right? With without ChatGPT or anything coming into the phase, the developer have to make some UI change and backend validation to get this done. Now think about this, right? Now it's just a text. If you look at the prompt, it's just a text. It's just like I say, this an analyst can do it, right? You don't need developer to do this. An analyst or who are subject matter expert, they can do it. So whenever they find a need, they can write a new prompt template and then put it in the system and then it ingests. So it's making it the entire process easier. But still, I would highly recommend having a human in the loop. Don't let because what LLMs can do really well is if you give an instruction, it will follow. I don't trust LLM beyond that, like being sentinel and then try to, so at least for now. So I would say like the one that solves the problem of um, you know needing to develop something to get a feature into your product. Instead, subject matter expert, business people, they can do it on their own. All you have to do is build a proper pipeline for them. They can just keep inserting 10 hundreds of template in there and then get it done. So you're making the entire business process a lot easier. Any other questions? If there is none, I can. Sorry, I think I didn't plan this before this long. Sorry for that. Thank you so much for your patience and please fill the feedback. Um, so during this talk, something that I didn't know, like what is the audience and where to dilute the topic and where to go a little advanced. That's a problem we had. Please fill this feedback. Give us what you want. Like you can tell us what you liked it because it was really difficult to introduce two topics and introduce them. I am sure like I may have skipped a lot of LLM stuff. So if you want, we can talk about it later, but please do give us this feedback so we can work on that. Thank you so much for your time. Good. So rather than using the API key, we can also use local language. Yes, you can do that.